Hi, in this video I'd like to go through XOR and XNOR gates. XOR and XNOR gates are very important when we look at the process of adding. And that's hopefully where we'll arrive at, but we'll take this a step at a time. This video will follow sheet 5, which is XOR and XNOR. So where do we begin? Well, first of all, let's write the maths out. An XOR gate essentially combines AND gates and OR gates. And it can also be built from NAND gates. If you remember those, they have the little there. So there's your input for an and you've got some combination of AND and OR. You can build an XOR, or you can use a NAND gate here. So let's just label that, just for quick memory. So some kind of AND OR combination, or an AND. Mathematics for it looks like this. There's your output. You get your two inputs. You've got A and B. We take A and we AND it with not B. And then we OR that with A, not A, B. So let's just represent that in terms of gates. Okay, so let's take each piece. We've got two inputs, A and B. The first one is an AND gate because they're multiplied here, but the B has a not in front of it, so we need in front of the B a not, and they both feed into one AND gate. Let's use a different color so we can keep track of this. Let's look at the second piece. Second piece, the A is knotted and it's with an AND gate with the B. So let's put a second AND gate here. This time the B simply just goes straight in, which is here, but the A has a knot. So I've got to try to draw that. Let's see if I can squeeze that in. There's a knot here. The output goes there. Let's squeeze it, jump over there and go there. Right, pretty badly drawn. Then finally they're combined through an OR gate. So drop an OR gate in, pop it there, and that's your output X. So that essentially is an XOR. How an XOR gate. So from your point of view, the crucial thing is this rather interesting combination of taking an input. In one case, you multiply, it's like a combination. In one case, you multiply the two numbers and you add them two multiplications, but one of them is knotted in the first one and the other one is. That combination is very, very useful and powerful, and that's called the XOR. Mathematically, it uses a different symbol, and so we leave traditional maths behind because we use a circle with a little cross in the middle, and we write that. That's how you write the XOR gate. And in digital terms, what does it look like? It looks like an OR, which you wouldn't be surprised because it's got this OR bit, but it's got this X bit here. So actually what you have is in front of it, you have another line here, and then your inputs. So if you like, it looks like an OR gate with a little line in front of it giving us our two inputs, A and B. And that is how you represent that mathematically. So next, let's have a look at the XOR truth table. So again, we've got, remember it's X is A XOR B. Right, so what does that look like? It looks like this. There's your input A, there's your input B, there's your XOR output, and the combinations are 0, 0, 0, 1, 1, 0, 1, 1. And what are the outputs? 0, 0 gives you 1, 1, 0 gives you 1, gives you 1, 1, 1 gives you 0. That's a very useful result. And we'll try to explain what the benefit of that is. So what is the benefit of it? Well, let's have a look. Let's go back a step. We had this 0 plus 0 in arithmetic terms is 0. 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 1, 0. Now, if you remember, that's a really, really awkward result. This plus sign, if we interpret this as an OR gate, the output of 1 plus 1 only gives us 1. So effectively with an OR gate, this bit is just cut out of the picture. Now that's a problem because we want to add two numbers together. And we can't add two numbers together if all we're doing is we're just taking this bit here when we do this for an OR. So the OR gate doesn't actually properly let us add two numbers. We have to combine this with the output of an XOR. So let's combine them in some kind of way. Okay, so if we were to combine them, let's have a look at what this would look like in terms of a truth table, right? So we've got our two inputs, A and B. Okay, that's the OR result, and that's the XOR. Now let's put our values in. We've got 0, 0, 1, 0, 0, 1, 1, 1. I never seem to draw this long enough. Right, okay. So if it's an OR gate, 0, 0, 0, 1, 0, 1, 1, and then according to the OR gate, we get 1 here. Coming over to XOR, we get 0. Again, we have 1, 1. So these three rows are identical with these, okay? But notice what happens right at the end. 1 plus 1 gives us 0. Now, if I can get you just to step back and have a look at this. Imagine I wrote 1 plus 1 and I put an equal sign here. 1, 0. Oh, you say, hang on a second. Are you telling me that if I can combine an OR and an XOR gate, I can actually output the correct result? I would say to you, yes, and that is one of the powers of the XOR gate. In your exercises, you're going to look at how this works, but let's just kind of clarify. Let's try to clarify how this works. So let's have a look at a very simple addition, right? We've got 1, 1, 0 plus 0, 1, 1. Now, when we go through this process, we start with this column here. 0 plus 1 gives us 1. Now, that operation can be carried out by an XOR gate for this one here, or an OR gate. So we're happy with the XOR gate. Let's move to the next column. We have 1 plus 1. Now 1 plus 1 actually gives us a 0, but it carries over a 1. So this is where it gets interesting. So this 0, we get the result from the XOR. This carryover comes from the OR gate. So then in the next column, we get 1 plus 1 plus 0. So we get the carry from the previous added to this. And again, we get a 0 here, which is using XOR. And we get the 1, which is using the OR. So here is an insight into how combining gates you can actually learn to add them together.